Started recording. Okay. So, right. So what we're going to do is subnet this 10.0.0.0 into 131,072 networks with 128 total IPs, 126 usable IPs. And then we need to find the 21,591st subnet, right? And it's going to take a little bit of time here, sorry. Well, I probably shouldn't even do this, but you know, I probably won't work. Let's just go back. I should be able to do this. All right, so the first network is going to be 10.0. All right, so this is the network ID. We'll go with first available, last IP, and then the broadcast. All right. So we know the next one is going to be 128. The next one is going to be 1.0, 10.0.1.128. All right. So first available is 1. Last available is 10.0.0.126. And the broadcast is 10.0.0.127. 10.0.0.129. 10.0.0.255. And 10.0.0.254. 0.1.1. All right. 10.0.1.126. 10.0.1.127. 10.0.1.129. 29. 10.0.1.254. and 10.0.1.255. All right, so there's enough here that you see that there's a pattern here, right? You know, it's going up 128 IPs, right? But there's 2 networks for each one of these, right? So when I do 2, if I do 2, right, I'll add networks. So the 10.0.2.0 and the 10.0.2.128, right? So there's 2 networks for each number in that second column, right? So what I would do is, all right, you're going to go from 0 to 255, right? In that second octet, but I'm going to need 2 networks for each one of those numbers. So that's 256 times 2, right? So equals 256 times 2, or 512 combinations, right? So that means by the time I get to 10.1.0.0, right, I would have gone through 512 networks. So that 10.0.255.128 will be my 512th network. Does that make sense? Right, I'm just counting, right? You know, 2, 4, 6, 8, right? 8, 10, 12, right? So 12th network, right? So 2, 3, 4, 5, right? So that's the 10.0.5.128, right? This is 10.0.3.0, 10.0.3.128, 10.0.4.0, 10.0.4.128, 10.0.5.0, right? So we're going up two times for each number, right? 0, 1, 2, 3, 4, 5. We're going to go to 255, or we're going to do it 256 times, so that when we get to 10.0.255.128, we'll have 500 networks. All right. Does that make sense to everybody? Have I lost you here? No? I mean, does this make sense? Okay, right. So for every 10.0.0.x, right? Dot zero, right? For every number right here in this second column, if you will, right? We have networks. So 10.00, 10.0.128, 10.0.1.0, 128, 2.0, 2.128, 3.0, 3.128, right? And this is just going to continue and repeat until 10.0.255.128. And then when we go one more, then we're going to get to the 10.1.0.0. And then it's going to repeat another 512 times until 10.1.258 or 255.128. So that's 1,024. That's the 1,024 network. Then the 10.2.258.128 will be the 2,048th network, right? 10.3.255.128 will be the 3,000. What is that? No, let's just this equal plus this 3,072, right? 10.4.128 is plus 1,024, because these are going up. Oops, five. I need to do 512. I'm sorry. Equals. Let me redo this here. Equals plus 512 equals plus 512, right? Because it's going up by 512 each time, right? 42, 25, 128. It's very close, right? Um, so what the best way to do is you get the 21,591 is what we want. So we equals that divided by 512. And it does equal 42, right? So 42, though, will get us to 10.41.255.128, right? So, but that's going to be equals 42 times 512, or 21,504th network. So now we take the 21,591 minus 21,540, and you get 87. That's your remainder here, this 0.169, right? That's your remainder. So because we have two networks, right, for that, so now we're trying to figure out what the second digit is. Well, technically we'll get the third digit too, because once we add one, we go to 1042. So we're going to divide this by 2 because there's two networks, right, for each number, right? And so we get 43 and a half more times. So what we'll do is we add 1 to this number, the number that you got, which that is 10.42.0.0. But then we need to go up 42. So we take this number minus 1. So we go up 42 and a half times, or actually go up 43 times. 43 times. Go up 43 times because we're zero based. So we'll go up to 10.4242.128, because that's that half time. So because 43, the 43rd number would be 42, right? And the half times is the 128, because we're almost to the next number. Does that make sense? But you just, yeah, I mean, you can get there easily by doing the 512, right, like this right here, and just adding the 512. And like I say, you'll get, let's see here, we'll do this as 5, and then equals plus 512. Actually, equals this plus 512, and we'll just always make it that one. So this equals 5 plus 1. So then we'll just say that this is, all right, so 42, and then we'll just do this. All right, so right, so this shows us it is between 41 and 42, but remember this 10.42.255.128, right? So you need to go to the 41, which is 21,000, right? So this is 10.41.258.128. Like I said, it's 21,504, right? And then you just need the 900. We're looking for the 21,590th network. So then you would just take this one, right, and then you can add the, until you got 90. So it's 21,504, 21,504, right? And so then you want to go till 90. And so you're just adding 1, right? You add 1, it's 10.42.0.0. 10.42.0.128, right? Oops. All right, and then you just would do that all the way into the 91st, right? And I doubt that would work, but and then so now you got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 0.6677, right? You just do it something like that, so it makes it easier. Um, so that, you know, 10.42.8.0 is the 21,052nd network, and you just keep going until you got to the 91st, right? That's one way. Or like I said, you can do the math. Just take 21,591 divided by 512, and you get 42, which tells you need 10.42 something, right? X.x. And then the remainder is the 21,591 minus 512 times 42, which is 87, right? So 87 networks from there. And then just remember that actually the this math here, the 42, right, is actually the 10.41.255.128 network. So you need to go up 87 networks from that one. Right. I know it's a lot. It's kind of it's a lot of math, and it is. But there's only one like that. Does that make sense? Is there anything too confusing? I mean, okay, good. Yeah, no problem. Any other questions from you or anyone else on subnetting? No. Okay. All right. Okay. All right. Let's go. All right. How did I open all those? All right. So let's go ahead and do a review for the final. Let's see here. Oh, just so you know, right, there's some static route videos out there that I put out there. If you wanted to learn about those, they're out there. And don't worry about the makeup exams. They're for special cases. If you don't know about them, then they're not for you. Let's see here. All right, so we'll go to the final exam. Here. Covers chapters 1 through 12. You'll have a 2-hour time limit. All right. I'm just going to submit it here. All right. Okay. So there's 60 questions. We'll go through 30 of them today, and then I'll go over the other 30 on Wednesday. But the best way to study these is obviously taking the quizzes, the chapters 1 through 12 again, and take them as many times as you can until you've seen all the questions. But okay, so on a Linux-based system, what command can you use to create a hash of a file using SHA-256, right? Wow, SHA-256 sum, right? You can create a hash file, and a hash file is a random set of numbers that can't be reverse engineered. So if you hash a file with this algorithm, it will generate a string of numbers and characters that only that file should produce. And so it's a good way to check and verify if anything modified in the file, because if you change a space or a single character in the file, it should generate a completely different number. And that's why hashes are important when you're downloading things from vendors or trying to do things. It's a way to prove nothing has changed and you got exactly what you're supposed to get, because you can verify the hash on the file and know that nothing has changed. Because if the hashes match, then nothing has changed. But yeah, so on a Linux system, you can run the SHA-256 sum to generate a hash. All right, what is the purpose of the checksum TCP field? All right, and it allows the receiving node to determine whether the TCP segment became corrupt during transmission. It's very, very much like the hash function up above, but this is used in our communications over Ethernet and using TCP, right? So it helps determine that nothing was corrupt during transmission. All right, an interface that manages traffic from multiple VLANs is known by what term? And that is definitely a trunk port, right? Our access port, that's a normal port, right? It'll be set to either VLAN 1, which is the default, or you might have new other VLANs. It'll be an access port. But if you want multiple VLANs on one port, so for your router, that's usually the use of this, to plug your router into a switch on a port on the switch and be able to have multiple VLANs. It's a trunk port. All right. A virus that remains dormant until a specified condition is met, such as the changing of a file or a match of the current date, is known as what type of malware? And that is definitely a logic bomb. It's waiting for some set of conditions to occur, like a date in the future, and then it goes off and corrupts or does whatever it's supposed to do, whatever damage it's designed to do. And that's called a logic bomb. Because there's some kind of logic, it just doesn't happen immediately. It waits. Okay. How do routers create a broadcast domain boundary? And it's because they don't forward broadcast traffic, right? So switches will forward broadcast traffic, but routers do not. So they cause a domain boundary. And so broadcast storms and things like that stop at the router. Which adaptation of EAP utilizes EAP MS Chat version 2? All right. Oops, let me see here. Inside of an encrypted TLS tunnel, right? So that's the protected EAP. That will be encrypted in a TLS tunnel and uses the Microsoft Challenge Handshake protocol. It's a protected EAP. So at least out of all these, it looks good. Yeah. All right. Let's see here. Okay. What field in the IPv4 packet informs routers the level of precedence they should apply when processing an incoming packet? All right. And differentiated services, right? It's definitely not the internet header. It's definitely not time to live, right? It's definitely not padding, right? This determines the level of precedence they should apply when processing an incoming packet. It's a differentiated services field. A network with 10 bits remaining for the host position will have how many usable host addresses, right? and this is usable. So it's 1022. And luckily, they don't have 1024, right? But 2 to the 10th power is 1024. You subtract 1 for the network and 1 for the broadcast, and you get 1022 available hosts, right, that you have for hosts. Packets that are smaller than a medium's minimum packet size are known by what term? And that's a runt, right? Or runts, just like, you have runts in a litter of dogs or cats, right? Small, right? They're too small. So packets that are smaller than the minimum packet size are known as runts. Which of the following IP addresses would be a loopback address? And that's anything starting with 127, yeah, right? And the 127.0.0.1 is the most used loopback address. What type of IPv6 address is FE80, etc., right? But with the FE80, we know that it's a link local address. Any address starting with FE80 is a link local address. What utility is the equivalent to the path ping command on a Linux system? And this one, right, they try to trick you, the trace route or the trace path, right, and hping, right, but it's actually the one that really doesn't seem like it would be. That's the MTR. What type of attack forces clients off a wireless network, creating a form of Wi-Fi denial of service? And it's a de-authentication attack, right? So, right, if it de-authenticates you, you get logged out, right? So you're knocked off of the wireless network. All right, what IEEE standard specifies how VLAN information appears in frames and how switches interpret that information? And it's 8021Q. Specification from IEEE. It's also why, on our 2960 switches, we're using the .1Q format of encapsulation, so our routers can find the VLAN traffic, because our switches use the 8021Q standard, right? So that's why we use the .1Q encapsulation, because that's the standard for VLANs. When using spanning tree, which port on non-root bridges can forward traffic toward the root bridge, right? Right. Only one root port, which is the bridge's port that is closest to the root bridge, can forward, right? Yeah, that's so you have root bridges, and you can have multiple root ports, but only the one that is the bridge port that is closest to the root bridge can forward. Right? Because you don't want everything forwarding, because it'll cause a circular issue, and you can overwhelm the networks. All right. A person posing as an employee strikes up a conversation with a legitimate employee as they walk into a secured area in an attempt to gain access. What kind of social engineering is this? And it's tailgating. They're trying to follow somebody through, right? And it's called tailgating, right? A lot of companies have gotten away to where you have only one person can go through a rotating door, right? To help prevent tailgating. That's why you have those type of doors for entry in a lot of IT areas, but even in a lot of businesses. It's to prevent tailgating. Um, so only authorized personnel come in to the area. You're troubleshooting a DNS issue on a Linux system and need to test the resolution of your domain mycompany.com's MX record or mail record, right? Using Google's DNS servers with the IP address of 8.8.8.8, what dig command will accomplish this, right? So we're doing a dig at the 8.8.8.8, the domain name, and we're looking for the mail exchange record or the MX record. So this right here is the full command. You need the at, the DNS server, the domain name, and then the record you're looking for. All right, you've been tasked with the creation and design of a network that must support a minimum of 5,000 hosts. Which network accomplishes this goal, right? So one is the smaller the number, right? The 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 more hosts you're going to have, right? Because the larger the number, the more host bits you're borrowing, right? So um, it would be the smallest number. The /19 is the smallest number. If any of them can do it, it could, right? Um, but then it's just a matter of taking. So we got 32 bits, right? 32 bits minus 19 is 13 bits. 2 to the 13th is 8,000, right? 8,000. If we take 32 bits minus 20, which is C, right? That's 12 bits. And so if we do 2 to the 12th, right, it's only 4,096. So only 19 is the one that can do 5,000. But just going by this, 19 would have the most hosts, right? 22 would have the least amount of hosts. So D would have to be the right answer just because it's the smallest number. Because if it was correct, none of the others should be correct, right? Um, because you're looking for the minimum number of hosts. And just as I showed, the math works out that, yes, D has 8,000 hosts, over 8,000 hosts, whereas C has only 4,000, just a little under 5,000, but it's under 5,000, so we can't use it. And then, of course, A, which is the next one, right? It's a quarter of what um, C has. It only has 10, which is 1,024, right? And then 23 would have 512, which is half of A, right? They just keep getting smaller as the number gets bigger. All right. When a device handles electrical signals improperly, usually resulting from a bad network card or network interface card, it is referred to by what term below? And then, right, so that's jabber, right? It's this electrical signals were improperly handled. It's jabber. A Windows computer on your network is having issues resolving queries for a specified domain, but not other domains. Other computers on the same network resolve the name just fine. What command do you issue that might fix the problem, right? So odds are if everybody else can resolve the name and you can't, it's probably a cache issue. Your DNS cache is out of date, and so then you can fix that by doing the ipconfig/flush DNS, which will flush or zero out your DNS cache. And so that will require your machine to go out and query DNS for the new IP address. So the ipconfig/flush DNS will most likely resolve this issue. All right, in order to prevent ports that are serving network hosts from being considered as best paths, what should be enabled to block BPDUs, right? And so we're blocking the BPDUs, and that's the guard. We have a BDU guard, C, right? In the event of a duplicate MAC address shared by two hosts on a switched network, what statement is accurate, right? Right. They will still send and receive traffic, but there's no guarantee that they'll always reach the correct destination. Because depending on when each one's sending and receiving, they may get the other's packets, right? Because they have the same address. So there's no guarantee that the traffic will ever be sent correctly. But it will send. It's just which one of them will receive the reply is anybody's guess. But it could appear as if you don't have connection to the network because you may not be getting the replies. When using diff/serve, what type of forwarding utilizes a minimum departure rate from a given node, which is then assigned to each data stream? And then so when we're using diff/serve, right, we're going to be using the expedited forwarding, right? You're just going to need to know because, right, there are all types of forwarding, but it's the expedited forwarding when we're doing diff/serve, because it uses the minimum departure rate for a given node. All right, what is routing protocol convergence time defined as? All right, and it is the time it takes for the protocol to recognize the best path in the event of a network change, right? So say you're switching a machine or a router or server or something, right? Or a switch from one port to another. And then for the time it takes for the network to realize the new paths, right? The best paths, that's the protocol convergence time. It's said that the network is converging and it's converged once everything's settled down and the change has been adopted. The wired equivalent privacy or WEP standard had what significant disadvantages, right? Uses a shared encryption key for all clients, and the key might never change, right? So it's very insecure, very insecure. The group policy utility can be opened by typing what name into a run box, and that's the gpedit.msc, right? So Microsoft console or MSC, it's a console, but it's gpedit to edit and work with the group policy. So it's the group policy editor, right? In IPv6, what field is used to indicate what sequence of packets from one source to one or multiple destination a packet belongs to? And that's our flow label, right? It indicates the sequence of packets from one source to one or multiple, right? It's our flow label. All right. when using DHCP for IPv6, DHCP version 6, what port do clients receive responses on? And so IPv6 DHCP uses port 547, right? 547 is for IPv6. Right. And you've been tasked with the replacement of open shortest path first with the EIGRP throughout your organization, which consists of a mixture of Cisco routers and routers from other vendors. What statement is accurate? As the EIGRP may not be available on non-Cisco routers because that is a Cisco proprietary routing protocol. The EIGRP is Cisco only. So it would have trouble running on the other routers from the other vendors. So this would be a bad move. Probably going to want to stay at the OSPF, right? Because it's not available for non-Cisco routers. All right. What command can you utilize to display TCP/IP configuration information for each network adapter installed? And that's just our ipconfig/all. All right. All right. So that's what I'm going to cover today. I will cover the 31 through 60 on Wednesday. But please be studying for the final. It is due on next Wednesday by 2:30. Right, the final exam lab is due 8 o'clock on Monday the 4th. Right, last day to submit anything to me though is the May 1st. Anything except for the final, right? The final, you have the ability, right? You do the final up until the final lab by the 4th and the final itself on the 6th. That's what I have for you today. Any questions or anything that you would like to go over? Okay. All right. Well, thanks everyone, and definitely, oh, and just